my name is Ms. Vazone, and today we're going to be talking about factoring using the GCF. So, what is a factor? A factor is something you talk about pretty early, late elementary school, early middle school. So a factor is a number that divides into another number. So a number, or it can be or a term, it can be variables, that divides into another number or term. The definition is a little confusing. A lot of students are like, wait, what? But it's really easy to understand once you see an example. So, for example, what is a factor of 48? 8 is a factor of 48 because 48 divided by 8 is 6. It divides evenly into 48. When we talk about factors, we're only dealing with integers, no decimals allowed. Blank is a factor of 75. There's a lot of options. I'm going to pick 25 because I know if I have 75 cents, I have 3/4, right? 3/4, 3 cents equals 75 cents. So these are examples of what a factor is. Now, more importantly, is a GCF. I'm sure you've heard of GCF, hopefully. GCF is the greatest common factor. The GCF is the biggest number or term that divides into 2 or more terms. Now, we shouldn't use the term biggest, but we tend to. Biggest actually refers to physical size. So greatest means numerically something that has a greater value. So let's say the biggest number, we're going to put this in parentheses, that divides into 2 or more other numbers. And again, I put numbers, but it's also terms. So we're going to be dealing with variables as well. And again, it's not really biggest, it's supposed to be greatest. Right? We really should be using the term greatest, but just for to make our lives a little easier, we tend to use the word biggest. Again, big means physically, like 3 is bigger than 7 because it's physically bigger. 7 is greater than 3. So that's kind of the idea behind those two words. Alright, find the greatest common factor of the following. 10 and 15, this one should shoot right out at you. What numbers divide into 10 and 15? Now I see a lot of students, there's lots of methods to do this. I'm going to show you my method, which of course is mine, so I like it. So what I do is I have my students write 10, 15, and then I say to them, pick any number that divides into both other than 1. Does anything divide into both 10 and 15? And I know 5 does. And then I divide. 10 divided by 5 is 2. 15 divided by 5 is 3. Does anything go into these? No. Right? There's no other factor other than 1. So, since we're done, there's nothing that goes into these two. This is our GCF. So our GCF is 5. And do the same thing with 18 and 48. Right. Pick any number that goes into both of them. I'm going to pick 3. 3 goes into 18 6 times. 3 goes into 48 3 goes into 4 once, carry the 1, 16. Now I'm going to take my 6 and my 16. Does anything go into 6 and 16? 2, they're both even, so I'm going to try 2 this time. 3, 8. Does anything go into 3 and 8? No. So that means I'm done. Then I'm going to take these two side numbers and I'm going to multiply them together. So my GCF is 3 times 2, which is 6. And that's finding the GCF using my backwards division. Again, there's lots of ways to do this. This is just my method. A lot of students can do this in their head. I like to have a method because what happens if you get stuck? What happens if you can't figure out the GCF? You need something to be able to do. Alright, a little harder, bigger numbers. Pause the video, try these two on your own. So we have 96 and 50. So those are bigger numbers, I'm not really sure. So I noticed they're both even. I'm going to divide by 2 and see what happens. So that's 48 and 25. Does anything go into 48 and 25? Well, the only thing that goes into 25 is 5, and that does not go in here. So I'm done. My GCF is 2. Sometimes you have those bigger numbers, and you feel like there should be a greater number that goes into them, but there's not. Alright, 70 and 20. This one cracks me up. A lot of students get stuck on it. Sometimes it's so simple, it's hard. So notice the zeros at the end. If you have zeros, what has to go into it? 10. Again, you could have done 2, you could have done 5, and eventually gotten to 10. 7, 2. So my GCF is 70. So that's finding the GCF of just plain integers. Now, let's think about what if we threw x's in? So let's focus on the numbers first. 10 and 25 should be pretty simple. The GCF of 10 and 25 is 5. So I know my GCF is 5 something. Now, let's think about the variables. X cubed and x squared. X cubed, comma, x squared. What divides into both of those? Well, they're x's, so an x does. X cubed divided by x, remember we subtract our exponents. X squared divided by x is x. Can I divide again? Well, yeah, I can put another x there. X squared divided by x is x. X divided by x is just 1. Can I divide anything into those? Nope, we're done. I'm going to take these, and just like before, we're going to multiply them. X times x is x squared. So my GCF is 5x squared. Pause the video. See if you can figure out number 6 on your own. Alright, so for number 6, notice I have 8 and 19. The GCF of 8 and 19 is nothing. So what do you think the GCF is if there's nothing? It's a 1. Okay? So my GCF is 1 something. Then we have x to the 4th and x squared. What do you think? Well, over here I had an x squared. X to the 4th divided by x squared is x squared. X squared divided by x squared is 1. Nothing goes into these. So my GCF is 1x squared or just x squared. So what do you notice about both of these problems? The GCF of the variables was x squared in both cases. Now why do you think that is? Because it was the smaller variable. Once you get past x squared, if I tried to divide x squared by x cubed, I'm getting negative exponents and fractions, and we said we only want really integers. So this is 1 over x, or x to the minus 1. We don't want to have to deal with that. So the general rule when you have variables is the GCF is the exponent, the smallest exponent. Okay? To find the GCF of variables, use the variable with the smallest exponent. And again, it's not technically the word smallest, it's the least exponent, but we like smaller because it makes more sense in our brains typically. Okay? Alright. Alright, find the GCF of the following. Pause the video and try this one on your own. Alright, so 7, I have 14 and 28. So 14 and 28, what do you think the GCF is? Well, it's 14. Okay. Could do 7. So my GCF is 14, and then look at the variables. I have x and I have x to the 5th. What's the GCF of those? X. Which one's smaller? There's an invisible 1 there, so 14x. Done. What's the biggest number that goes into both 4 and 36? Hopefully you recognize that 4 goes into 36. And then we have x cubed and x7. Who has this? Which one's smaller? X cubed. And we're done. Alright. What does it mean to factor a polynomial? So now that was kind of just leading up into this idea of factoring. So remember our definition of factor was something that divides into something else. So it's kind of, that was like the noun factor. Now we're dealing with the verb. So factors multiply to a number. A factor divides into a number. So here, there's a few ways to think about it. The big one, the real definition that I use with my students is writing a polynomial as a product of 2 or more other polynomials, or 2 polynomials. So writing a polynomial as a product. If I wanted to think about this in terms of numbers, 48 is 6 times 8. I factored 48 into 6 times 8. Or if you think about back in middle school, in elementary school, a factor tree, we're writing it as a product of other numbers. Okay. The other way to think about it is it's the reverse of the distributive property. When we distribute, remember that's with parentheses, 3 times x plus 2. We're distributing that 3 in. This is a product. We're multiplying 3 times x plus 2. So now what we're going to do is we're going backwards. We're going to have our 3x plus 6 and write it like that. Okay. Alright, so factor using GCF. So we have 10x cubed plus 15x to the 4th. Now think about what we've been doing previously in this video. Why do you think I taught that to you? So the first step is find your GCF. So my GCF, I have 10 and 15, the GCF is 5. And then I take who has the smaller exponent, x cubed. Now, since this is the reverse distributive property, like I said, what's the opposite of distributing? With distributing, we multiply. So to factor, we're going to divide. So we're going to take our 10x cubed plus 15x to the 4th, and we're going to divide out 5x cubed. So we're going to divide the polynomial, or the binomial. So 10 divided by 5 is 2. X cubed cancels out, plus 15 divided by 5 is 3. X to the 4th divided by x cubed, remember we subtract, 4 minus 3 is 1. Now, this is an expression, not an equation, so we can't just magically divide. Remember, it's a reverse distributive property. I want this to look like a distributive property, so now I'm going to put my GCF on the outside. And that's the answer. We just factored by pulling the GCF out of that binomial. Let's do another one. This one I like to go over because it's so simple it's difficult. So step 1, GCF. What's the coefficient of x squared? It's really just a 1. So what goes into 1 and 7? Just a 1, right? That's called relatively prime. And then we have x squared and x. Take the smaller exponent. My GCF is just x. X squared minus 7x. We're going to divide by our GCF in order to kind of pull it out of the problem. X squared divided by x is x. Minus 7x over x. This x is canceling, you'll have to put 7. Parentheses, GCF on the outside. Again, because this is an expression, you can't magically divide. We divided and then we're also multiplying it, so we're not changing the problem. Alright, pause the video, try 11 and 12 on your own. So our step 1, find our GCF. So my GCF here, I've got 48 and 6 is 6. And then who's smaller? X squared is smaller. Now we're doing the reverse distributive property. We want to write it as a product, so we need to divide. 48 x cubed minus 6x squared over 6x squared. 48 divided by 6 is 8. Here, 3 minus 2 is 1, so x to the first. Minus, now here's what happens. A lot of students, that just cancels away. But what's 6 divided by 6? 1. Don't forget the 1. That cannot just magically disappear. So that whole thing cancels to 1. Parentheses, 6x squared. And these are nice because they're really, really easy to check. All I have to do is distribute, and I should get back to where I started. Alright, number 12. GCF. Now this one's a little harder. I'm going to make my little GCF, because I honestly don't even remember the answer. I'm going to try it 2. That's 50 and 16. Another 2, 25 and 8. Alright, nothing goes into 25 and 8, so my GCF is 4. And then x5, x8 is x5. So then we're going to divide 100 x8 minus 32 x5 all over 4x to the 5th. When I divide, it's 25. X subtract, when I get x to the 3rd, minus, here we get 8. And notice those numbers are right there, which makes it nice. Parentheses and GCF on the outside. And we are done. Oops, is that it? I thought I had one more. Guess not. Alright, that's factoring using GCF. Hope this helped. Have a great day.